Practice exam 2, part 8. We're on question 13. We have our premises listed. C, if C, then either not D or A. Not if D, then A. And our conclusion is not B. Okay. Sorry, it won't be in the screen the whole time. What do? We remain conclusion driven is the mantra, how you should solve these. Okay, good. We ask ourselves, where does that conclusion, not B, occur plus or minus a negation amongst the premises? And what do we notice? Right away, okay? We notice something very important which gives us a clue to how this proof goes. And if you're not very well practiced in proofs and you don't know what can and cannot be done, you'll be freaked out and you'll think, oh no, how do I proceed? B, so where does this occur plus or minus a negation amongst the premises? Nowhere. There are no B's. There's no B's anywhere. We've got C's and we've got D's and we've got A's, right? Which means we need to pull, right, so you might freak out if you think the proof must be impossible. It's not true, right? It's not the case that the proof must be impossible. It's the case that the only way you can derive this completely new formula, which isn't contained anywhere amongst the premises, as any kind of sub-formula, the only way you can get that is by adding it to something else. And the only way you can derive this by itself is if there is a contradiction amongst the premises. So remember from the text, if there is a contradiction in the premises, right? So it's, if there is a contradiction in the premises, anything at all follows. You can derive anything at all. This is called the principle of explosion. Okay, so the form of your proof is going to go something like this. This is the form you sort of want to be put in mind of if you're thinking, I'm going to have to get this by. If I'm going to have to get this formula, you're thinking, okay, I must have a P and a not P amongst my premises. There has to be a contradiction in the premises if I'm going to be able to get not B, this entirely new formula, out of the premises. Okay, so how am I going to derive Q, something new? It's going to be, this is the form of the proof. It's going to go like this. I'm just going to add Q to one of these formulas, P will do, and then I'm going to use the negation of it to do a disjunctive syllogism to that one. Eden, please. What are you doing? Yeah, very good. All right. They're trying to learn. They've got an exam coming up. All right. Don't touch the computer though. So that's how you're going to do it, right? That's how you derive any formula at all. Q, potential variable, stands for any formula at all, if you've got a contradiction amongst the premises. So be aware that you don't freak out if you see something like this. Well, this isn't even in the premises. How on earth is this proof possible? It's possible if there's a contradiction in the premises, which is true, we'll see, of these of this problem. And that's the form of the answer, right? If you've got a P and a not P, just add to one side, use disjunctive syllogism to get you the disjunct you just added, right, to get that all by itself. Okay, so if we go back to our particular question 13, we've got an obvious modus ponens to happen. Step 4, got a conditional and the antecedent of it, so that gives us not D or a 1, 2 modus ponens. And if you look at 3, stop it, mate. I'm trying to teach these kids what they need to know for their exam. Okay, I've got, if you look at 3 and 4, you will notice that this is your P and not P, right? If you only just transform one or the other. You could do a conditional exchange on the subformula on 3 to get not D or A inside the brackets, so you would have precisely this negated, and then you'd have two formulas in the form of P and not P. But I might just do conditional exchange on 4 by itself. 4 CE. Let me back that. Okay, so I've got, now I'm looking at 3 and 5, right? So So let's just go like this. 6. I'm going to add to 5. D, hook A. Stop it. D, hook A. Or not B. Right? I'm adding that one that I want. Right? That's I've added to 5. Sorry, that says add. Added to 5. Okay. And look at 3 and 6. That's actually going to get me home. So, okay, if I look at 3 and 6, 3 and 6 with the not B, and destructive symmetry. So DS, right? DS 3 6. That's how I get home. And then just put the number on. Step 7. And that's that. Okay. One more to go.